In this video, I will be talking about projections, and it is something that we touched based upon in the intro class, and it is something that we will be talking more about in the intermediate course. So every GIS dataset you work with should have a projection. There are a lot of projections out there that have been created to support specific areas. So for example, there are projections for specific countries, different states, and even projections made specifically for the entire world. Luckily for us, we don't have to make a decision on what projection a dataset should be in. In many cases, the data owner, the creator, or even the person who maintains the dataset have established a projection already. So for example, if you get any data sets off of the MassGIS website, most data sets should be in Massachusetts state plane meters in NAD 1983. Another example is if you get data sets off of the Rhode Island GIS website, most of their data sets should be in Rhode Island state plane feet, NAD 1983. And then finally, if you get any GIS data off of the USGS website, all their projections should be in either decimal degrees or UTM. Here I have a blank MXD open, and I am going to show you how ArcMap deals with projections. So as you can see, there are currently no data sets. I am going to throw out the term projections on the fly out there. We love projections on the fly, but sometimes it can create a problem. So let me show you first how to read the coordinate system off of a data frame. So here I have my layers data frame. I am going to right click on it, go to properties, and right under the coordinate system tab, there is a box below here. It says I don't have a coordinate system set at the time. So the thing is, the first GIS data set that you bring in, whether that's a shapefile, a raster file, into ArcMap, the data frame will set the projections for everything that follows. So let me close out of the data frame properties, and I am going to bring in a shapefile, and this is the outline of the town of Easton. And let's take a look at the coordinate system. So what I'm going to do is I'm going to right click on Easton. I'm going to go to the properties, and right under the source there should be a projected coordinate system, and right here it says it is the NAD 1983 in the state plane Massachusetts. So I'm going to close out of that, and I'm going to go ahead and take a look at the data frame properties. And I'm going to right click on layers, go to properties, and right now the coordinate system, it reads the same exact coordinate system as the Easton outline. It says the NAD 1983 state plane Massachusetts. So as I mentioned before, whatever data set you bring in, the data frame will copy the properties of the projection. So now let me bring in two more data sets. I am going to bring in two Easton data sets that are in two different projections. So let's take a look at the Easton GCS and also the Easton UTM Zone 18N. I'm going to right click on the Easton GCS first and go to its properties, and I'm going to take a look at the projected coordinate system. So right now it says the geographic coordinate system is the GCS North American 1983, which is in decimal degrees. So I'm going to hit cancel, and now let me take a look at the Easton UTM Zone 18N. I'm going to go to properties, and under the projected coordinate system, it says NAD 1983 UTM Zone 19N. And here it is in meters. So as you can see, we have currently three different shapefiles of Easton with three different projected coordinate system. Let me change the color of the Easton UTM Zone 18N. And let's take a look at all three shapefiles. So let me uncheck Easton SPM just so we can take a look at Easton GCS. And as you can see, they stack and align perfectly on top of one another. And let me check Easton UTM Zone 18N, and same thing, they all stack perfectly on top of each other. And this shouldn't be the case because all three have three completely different projected coordinate systems. Now let's take a look at the layers data frame. I'm going to right click on layers, go to properties, and right under coordinate system, as you can see, it is still the same coordinate system. It's the NAD 1983 state plane, Massachusetts. Now, this is called projection on the fly because the data frame takes the coordinate system of the first data set that you add into ArcMap. And any data set that you add following it will also take the same coordinate system, despite the fact that they may be in different coordinates. Now, what this means is when I added the first data set, which is the Eastern State Plane, Massachusetts, the data frame properties took the same coordinate systems. And then I added two more Eastern shapefiles, which have two completely different coordinate systems. And when I added those two coordinate systems, what it did was it adopted the same exact coordinate system as the first data set, and also the data frame properties, which explains the reason why they all stacked up on top of one another. So in order to fix the issue with the projection on the fly, what I can do is in the drop-down list right under the globe icon, you can select clear and then hit apply, and the projection on the fly should have been removed. So after removing the projection on the fly, now let's take a look to see if they still stack on top of one another. So let me uncheck Eastern SPM to take a look at where Eastern GCS is, and currently it is no longer right underneath Eastern SPM. And let me uncheck Eastern GCS to check Eastern UTM Zone 18N. And again, with the same thing, Eastern UTM Zone 18N is no longer underneath Eastern SPM. So let me check everything and turn everything back on, and let's select full extent to see where everything else is. And as you can see, there are two shapefiles here that are located within a distance of one another, but not stacked on top of each other. So let me select the zoom in button and zoom in. And as you can see, this is the Eastern Zone 18N, which is right on top. And let me go ahead and zoom in and take a look at the other one. So I'm going to select full extent again, and I'm going to zoom in down here. And as you can see, they are no longer stacked on top of each other, but they are located within a few distance away. So that's the way it should be. Since they are two different coordinate systems, they shouldn't be stacked on top of one another.